Welcome to BIMThoughts. We've made it. We're having another video. Can you tell that we're having a video conversation? Well, if you're listening on your podcast player, you can't, because you need to go to the YouTube one to see the video. But you can obviously continue to listen here, and we'll be happy you did. And I'm sure you'll get a lot out of it. We have a lot of people with us today. We've got the Carl Storms. We've got the Dana Del Flip.
Gosh, you do so well typically. Gosh.
Del Philippi.
You just got out of a meeting.
I got it. Oh, whatever. Who cares?
Let's give it another try.
All right. We got the Dana De Philippi here. And we have Alexis. And I'm going to butcher that last name, Alexis.
Go for it.
Got some basis.
I'll
got
take
some
that.
basis.
I'll take that one too. It's a very versatile name.
And we have Mr. Rhino.Inside and Mr. Python.Inside.Revit. And I'm not even going to try to pronounce your name because I'll get it really wrong, because I'm a white American guy that doesn't know how to pronounce anything.
Well, look, it's kind of hard to pronounce. The S is right after H, so it confuses everybody. It's oh, that's misspelled. Name is Ehsan, and the family name, I read my family name as Iran-Nejad. Although it doesn't have a hyphen in the middle. So everybody thinks Iran is my middle name, but which is a happy coincidence. The name of my country is actually my middle name here.
Well, define yourself. Tell us who you are.
That's a long story. Which version would you want to hear?
Whatever story you want to tell.
So I guess we can start. I started from the backgrounds. I grew up back in Iran, my country, and my dad was a telecommunication engineer. And since I was a kid, I always loved playing with tools and making stuff. So I guess in that regards, you could sort of categorize me as kind of a maker mentality.
I'm a maker, can you tell?
Yeah, 100%. So that kind of a mentality. But then I grew up, and I think it was I was 10 or 12 years old that they brought computers to our school. And I always joke about it that I went to that computer class and I'd never really left. So I'm still learning and learning and learning. So from that point on, I figured out, oh my God, I absolutely love this thing. This is just magic.
Just when you thought you learned everything, someone like you comes along and creates something completely different that we all have to start to learn again.
Yeah.
And I'm sure your two little platforms, which are fabulous, by the way, I'm sure you're learning a bunch about them as well, and about different ways that people are using it that you never thought of.
Oh, wow. Yeah, absolutely. So anyway, grew up and then, ended up studying architecture for whatever reason that you don't want to get into. I ended up studying architecture, left architecture, but finished my architecture school back in Iran, and then worked for a couple of years. And I really didn't like the industry there. So I kind of started doing a lot of open source, a lot of freelance projects. And I had a electronic engineer's friend that he taught me microcontroller programming. So I did a lot of embedded programming stuff back then, all C stuff.
Yeah.
And then I got the opportunity to move to the US, and I came here, and I didn't have any, all the work that I'd done was my freelance stuff. So I didn't have much of a resume that I could apply for anything except for the architecture on all those projects and whatnot.
Yeah.
And I told myself I can give architecture another chance. And I sort of I actually lived in Houston for 4 years, got my license there, moved to Portland, still worked as an architect for a couple of years. And then back in 2017, I got to a point that I'm I kind of know where I'm going in architecture, and it doesn't really excite me as much. And I want to sort of go back and focus on the love that I had for computer science and stuff, because that all lived with me throughout all these days. Computer science was still my number one passion, but it wasn't my profession at that point. So I'm let's at least merge these two together. Let's bring your architecture experience and computer science experience and put it to use in one place.
That's what's cool about our industry, about the AECO now, industry, is there's different paths you can take. You can go down the path of being an architectural draftsman and designer and be happy there and continue on that path. You can branch off and get your license and become a full-fledged architect.
Mm-hmm.
You could take a completely different branch like we did and go into the information side of it, go into the computer, the technical side of it. And all of those sides are great paths to go through, because that's why we're all different. That's what makes us different.
Yeah.
And that's what makes architecture so great, and engineering and all that so great, is we can get started in that path, get started in the industry, get our experience. So now when we go, oh, you know what, I want to jump to this company and become the BIM manager, for example, you have 5-6 years of experience in architecture, so you're one step further along.
Yeah. Actually, we have, back in Iran, we have national exams to get into university. So you have to, like, everybody throughout the year takes a national exam based on your score. You get sort of like assigned a couple of like the programs that you have selected. You can, I think at the time, like, I don't know, 50 or something like that when I was taking the national exam. And then from then, based on your score, you get passed, you get sort of like assigned one of these. And my grades were good enough to get to computer science that I wanted to go to. So I ended up studying architecture, which was my second choice. But it was still very exciting to me because it was, first of all, it was multidisciplinary, which I really liked it. You get to talk with like many people, many different types of people, engineers and all that kind of stuff, from designers, very design, artistic kind of mentality, to like to engineers with a full engineering way of thinking about stuff. And then the other thing that I got sold on was this thing that, hey, like, I listened to Pink Floyd a lot back then, and people are like, well, Roger Waters studied architecture, and so there's this huge list of people like filmmakers and directors and all that kind of stuff, musicians that actually sort of like studied architecture first and then transitioned to whatever they wanted to. So it was always interesting to me that architecture has this tendency to teach you a lot of skills that it's sort of like, it's universal, that you could use them in a lot of different areas and domains.
Yes, absolutely. Well, let's jump into the Pythons and the Rhino.Inside stuff. So what the heck made you do that? Why did you you thought, oh, I need to make this, or you made it and thought, oh, I'll just give this away?
So, you know, like in the back-end AutoCAD world, all of us kind of knew how to write a couple of Lisp scripts and get things automated in a certain way and whatnot. So I kind of came from that background, obviously. And then when I moved to Portland, the company that I started working with, they were using Revit heavily. And that was sort of like my first job that I was like using Revit on the actual projects. And I started using it, although I kind of knew how the software works, I never really actually used it in production environment. So when I got to a point that I sort of like got really good with like just running the software, understanding the project and the basics, then I realized this software doesn't have any automation system. Like, it has an API and you can actually write plugins and stuff for it, but there's no scripting environment that I can get things, collect things. Like, let's just round up all these room areas for me without like having to go and create schedules and fiddle with totals and all that kind of stuff. That's when I knew Python, so I'm like, let's see if I can like merge these two together. And I found the Revit Python shell project, which was like a tiny shell, still available for Revit. You can just run it and it gives you Python access to Revit API. That's when I started writing like Python scripts to get stuff done, like calculate things that we use in metrics and whatnot that we use in architecture, like for code calculations and all that kind of stuff. And then after a while, I realized, well, I have like 20 of these scripts, and every time I want to run them, I have to go and open and click and select the file and find that script and then run it and whatnot. And then you have to fiddle with the script every time you want to run it on a certain project, because like you don't have any GUI attached to it and whatnot. So that's when I sort of like wrote a just massive monolithic big single script that I would attach to Revit Python shell. Let's call it RPS from now on. And it would bootstrap. When I launched Revit, it would bootstrap and find all those scripts and create a bunch of icons in Revit's user interface for me. And they were kind of helpful, and I sort of like we made them more generic and whatnot, so they could apply to other projects as well. And at that point, I was like, well, let's actually start sharing this with other people so they can save a little bit of time too.
Right.
That's when I actually published the project on GitHub. But it sat there for a while until Guy Talarico, he was actually, I think, the first PyRevit user. He downloaded it and he used it, but after a while he wanted to make some changes to it, and he's like, well, this is really complex. Like, it's just one script, and I know there's no documentation. And I wasn't a really good programmer, so I learned Python program, like actual Python programming on the job on PyRevit. So that's when sort of like how the PyRevit really started, and after that it was just keep adding and adding and adding more tools to it as I changed projects. And
first time I was introduced to it was at Built in Seattle.
Oh
yeah.
And what amazed me is when I walked into that class, I thought, well, I'm going to sit down and I'm going to start typing Python, and I'm going to make Python do cool things inside of Revit. But then I realized pretty quickly that, oh, wait a minute, I can do that, but there's all these other tools that are already made that I don't have to write all of the scripts. A lot of the scripts that I would have thought that I wanted to write, they're already done. They're in the menu. Away you go, which is fantastic. So if you haven't tried it, please do. I mean, it's worth the ride.
Well, I think that's really beautiful, because that's what typically when we tell people to learn some sort of programming, whether it's Dynamo or whatever it might be, it's because they have a problem, right? And it sounds like because you were in production and you're like, why doesn't Revit assign revisions this way, right? Or why can't I create a material easier than figuring out the math behind some crazy text note file? Right? Like actually working in the program and in the process and understanding the limitations is what got you to learn to code. And I think that's inspirational in itself.
Absolutely.
Yeah. Yeah, that's 100% true. That's, for me, it was like PyRevit at least was the primary purpose of it was to just solve my daily problems. I mean, it eventually became something that was more than that slightly, but it's still a set of tools that I use on a day-to-day basis on the job. It started really taking off after I added that pattern maker tool, because I started making Revit templates at some point, and I was like, well, you know what? I can't make patterns this way, and I don't want to pay $65 for a license for another add-on. Because I was like, obviously you're working for another company and there's only one version of this, and the BIM manager has, and everything you want to make, you have to go through like 5 different people to get a pattern made and tested and whatnot. So I'm like, okay, let's just go and figure this thing out. And I'm not a mathematician, and I'm not really good at math, to be honest with you. But I sat down for a couple of days and I'm like, let's just figure this thing out, how to read a whole bunch of coordinates from a bunch of lines and figure out in reverse, try to figure out how the actual path file would be written. Wow. And generated. And that was, I think that's when I published that was one of the key turning points for PyRevit. A lot more people have started picking it up. I got a lot of requests from people that, can you just, give us the pattern maker? I don't want the rest of this stuff in here. A lot of people can do damage to their models with them.
That's true. I will say there are a few tools as a BIM manager, like wiping some of the things out, which are amazing as a BIM manager. Don't get me wrong, because a lot of those features, as I'm sure you know, I don't have to tell you, but for our audience, you can't get to, right? I mean, you can't delete view templates that aren't in use wholeheartedly, or view filters, or things like that. And so to be able to get in there and delete them, but a lot of the times as BIM managers, we don't want people purging things like that from our templates, because then they usually ask for them later. Right?
Exactly.
But no, as a BIM manager, it's kind of like one of those tools that you're saying, like the one person, the BIM manager gets to have it. You get the BIM suite of add-ons, and you get to have PyRevit because we trust you.
Yeah.
Any other tools besides the Hatch tool that you've gotten a lot of feedback on in terms of they love it, they hate it, whatever it might be?
So I guess the most popular ones on the pick and selection tools, the pattern tool is very good. In the past year or two, The Keynote Manager has received really good feedback. The match properties, renamers, a couple of these tools that are sort of like more on the management side of like how you maintain a clean Revit model kind of set of tools. Those has been the ones that I've got the best feedback on. Obviously, like all the tools still are buggy, and like, you know, every once in a while there's like troubles with the back end and all that kind of stuff. It doesn't get attached to Revits correctly. Sometimes I break things constantly, and that's partly because it's sort of like a single man project at this point. There's a couple of contributors to the project that send us PRs to be merged and whatnot. But in terms of having somebody that can take care of the project in a day-to-day manner, finding that is kind of hard on open source projects in general. A lot of these projects evolve very naturally, so not all the core is documented. It's kind of hard to figure out what parties works with the other part and whatnot. And that's sort of like that's one of the main challenges in getting more developers inside the actual core and helping building the tools and stuff.
Alexis,
But
I
then,
see your
of
gears
course,
are running there.
I'm sorry, I'm a bit sort of starstruck here. I'm a massive fan of PyRevit and like started using and learning it last year. And the PyRevit tools for me are just like the surface, the tip of the iceberg in terms of the customizability. Sorry, can't get my word out. Being able to develop our own apps and being able to open up all these apps that have been pre-made and see how they're built. That's like essentially how I've learned Python. You know, from knowing nothing to opening up these apps and reverse engineering and figuring out, and then going onto your site and seeing like every day is like Christmas. You've got like for developers to have logging analytics or telemetry, adding HTTP now in your next version. And it's like a lot of this is still way over my head, but I think that's also the exciting part of it is every day you're discovering something new, and it's all free, like it's all open source and based off of kindness of people like you and other contributors who are driving this innovation in our industry. And the tools that Dana was just talking about, being able to, like every architecture firm has its own needs, right? So Revit is a powerful tool, but it doesn't meet all our needs. And something that I really need for my practice might not be something that is marketable for Autodesk to create. So you bridging that gap, giving us the power to build these things for ourselves and make our lives easier.
Yeah, one of the things that's really helped me sort of like understand how softwares really work and what kind of software is appropriate with what kind of industry was that because I lived back in Iran when we didn't have any like copyright laws and stuff like that, I had access to see other softwares. Like I could see Maya without really being able to having to buy a license for it. It's not being used in the production environment or anything like that, but it was great for me to see, hey, look, when you make a professional software that is used in production mode, it kind of comes with its own language because it's understood that there's a lot of like basic runtime core stuff that it's in the software, but you need to be able to customize and merge them in different ways and put them together in many different ways to get to what you want. Like great example of this is sort of like the suite of 3D modeling like Maya and Blender and sort of like animation kind of software. You see it touches many different paradigms from modeling to animation to rendering to shading and all that kind of stuff. And a lot of like in case of Blender, you see all of that happening in the same software without having a good solid kernel and the ability to build on top of it. In case of Blender, still uses Python to build the automation on top of everything else. Without really giving this customizability to the users, you can't provide everything that everybody needs. There's no way you could do that. It's just the target the use case that's it's targeting basically is just too big. Exact same thing with the AC. And I think Revit was a good start, but it sort of like went in a different direction, said, hey, a wall is a wall, and you can't change this. This is the definition for the wall and how the wall is supposed to work. So it's sort of like tied down things a little bit more, and it didn't provide much of a big API over it after it got added when I think Autodesk bought the software. But as an architect, as a user of the software, for me, having the need to go to Visual Studio and write C# and compile it and then run Revit and test my application and close Revit again and modify this stuff. This just the development cycle is a software developer kind of development cycle. It's not a user kind of development cycle.
Right.
The user needs to be in the software and fiddle with things and make the changes and change scripts and whatnot.
And that's a big barrier to entry on the API when you have to use Visual Studio, compile it to a DLL, put the DLL in the right spot, hope like heck it runs. It's difficult. It was difficult for me to get into that. Yeah. And that's probably why I didn't do much C# or VB inside of Revit. Yeah. But now with your stuff with Python, it's easy.
Yeah, especially like you can put another level on top of that thing that, hey, I'm using Revit and I want to develop for it, but this is a specific thing I want to test it on this project. And that project file is 3 GB and it takes 20 minutes to open. So it breaks your development cycle completely, because I'm like, I can't be closing and running and opening this application.
Right.
That's the main drive behind why PyRevit behaves the way it behaves. It's like, you don't need to close Revit, just reload any, just PyRevit rebuilds and recompiles itself from scratch, and basically comes up with a new core. And then every time you click on a script, it runs the newer version of that script. Whatever you have in the file, you can go change stuff and just click on the button again, and it runs a newer version of that script. So in that case, was super helpful to me. A lot of times, especially at the start of the project, I had the scripts open on the side in a script editor, and I would go and make change to some of the variables, and then I click on it, and it would run differently on this project. And then, like on a different project, I would make changes to a different set of variables and run it differently. It didn't have any UI. The UI was the actual script that I was making changes to the values and settings and stuff.
Yeah, sometimes making the UI is a lot more difficult than just writing the code in the background. But the UI is what makes sharing it easier with your coworkers.
Yeah, and so, as Alexis mentioned, sort of like PyRevit started growing beyond the base tool set to have like a command line utility that can help you attach things and manage the Revit environment and whatnot, the PyRevit environment, and then a telemetry system that you can configure it to collect all sorts of Revit telemetry and send it to your own databases. There's an HTTP API now that you can build your own HTTP applications on top of Revit, and you can call Revit from it outside. To run Python scripts or whatever you want to do on it. So it sort of like started growing into a whole framework of things that you could do as part of development on Revit. And throughout these years, I kind of realized, hey, I'm kind of a framework kind of person. Framework people. I like to make tools that other people use to do other things with. So that's sort of like, you know.
So tell us about Rhino.Inside.
Yeah.
That's the second big one.
Tell us how you migrated to that from PyRevit to McNeel, and how you made that transition.
So that's kind of an interesting story for me, because I'm like, McNeel is the first official software company that I'm working for. Although Bob doesn't really think of it as a software company, and we'll talk about it. I really like his mentality, the way he approaches the business. But it was a happy accident for me. When McNeel started distributing and sort of like giving Rhino.Inside.Revit to their users and whatnot, they realized there's this plugin called PyRevit that they're conflicting with, and because there's like a DLL conflict and stuff like that. And that's how Scott contacted me, and it's like, well, you're the developer for PyRevit, we have this issue, let's work together to get it resolved. And we worked together and got it resolved. And I went to the Build conference in Seattle that they had a presentation on, and sort of like help out with the PyRevit stuff and whatnot. And that's where I actually met Scott and a couple of other McNeel people. And then a couple of months after that, Scott and Bob were coming down to Portland to meet with one of their clients, and we had lunch together. And pretty much after that, Bob said, "Hey, do you want to come work for McNeel?" And I was actually during it sort of like I was actually interviewing with another company in San Francisco to see if I can like transition there and whatnot to as a different software company. But I liked the people and the mentality behind McNeel's business so much that I'm like, this is right. It's my kind of a company. I think the same way as they think, and they think it's the same way as I think about stuff. So that's how I ended up kind of in McNeel as the Revit guy.
And how did Rhino.Inside come up then out of that?
Oh, so Rhino.Inside has been going on in the past year and a half. This is way before me. When the development team, the Rhino development, separated the core of Rhino from all the exterior stuff, and they were able to put Rhino inside other applications. One of the main developers at McNeel, Kike, he is one of the main developers for Visual Arc. It's a whole BIM suite for Rhino that you can make. It turns sort of like Rhino into a BIM application for you, so you can have all these like BIM logic and doors and all sorts of like architectural elements that we deal with inside of Rhino. So he had a very good knowledge of like how the industry works in that way and what kind of challenge he's dealing with. And he knew about Revit, so he started putting. And they got a lot of like requests from the users that, hey, we want to bring Rhino models into Revit. And the solution that they came up with is that let's just put Rhino inside Revit and create a geometry converter between the two. And that's how the Rhino inside Revit kind of started. It didn't have much of a Grasshopper components back then. It's just started as a sort of like an API. But a lot of Rhino users are really good at Grasshopper. It's just so easy to make things and play with things in Grasshopper and put some logic in there. So that's a natural evolution of Rhino inside. The Grasshopper stuff started happening. And then they showed it to a couple of other people at presentations and stuff. They got a really good bunch of feedback. But at some point, they kind of realized, well, we don't really know Revit enough. Revit is weird. There's a lot of like intricacies and idiosyncrasies about this software. We don't really know how people actually use it outside. And they kind of felt the need that they need somebody to bring that experience into McNeel. And I guess I was just the lucky guy at the right spot at the right time.
That works.
Yeah.
It's been an issue that practices have struggled with for years, interoperability between Revit and Rhino, because one can't do the stuff that the other can do. So this,
or even just the design team and the production team, right? Like that's the two stages of the project are so segmented that it's hard to marry the two.
Yeah. I was talking to Scott a couple of days ago, and we sort of like started talking about this in terms of level of detail. And we were like, well, when you're in the design phase, you're kind of like LOD 100, 200 or whatever. You get to like boxes and general areas of like where things are located and whatnot. You don't want to get into too much detail. You don't want to see the actual shape of your columns and the structural elements and whatnot. You just want to have general things in there. There's the most important thing is about the logic behind how you are creating the facade, for example, and all that kind of stuff. And then when this Rhino Inside piece helps you transition from that model that you have creating using a more flexible design kind of tool, and bring it into and attach all the extra metadata and whatnot, and use the API to create the actual native Revit elements inside of Revit and take it to the next level. Start building the LOD 300 and 400 model, 300 and 350. And then it helps you again at the end of it to grab all these stuff that you have made in there and start making fabrication drawings out of them. Whether you want to grab them from Revit or tie it back into your Rhino models again, you can start making fabrication, because like a lot of the different fabricators work with these kind of models. If you want to send it to a 3D printer or a fabricator, they'd rather get the sort of mathematically accurate NURBS geometries and all that kind of stuff.
Carl, I'm sure you have a question.
Never. I'm just sitting here in awe of all the intelligence that's thrown around and hoping to soak some of it up through osmosis.
How's that working for you?
Well, you know, I think digitally it's going great. I'm going to go write some Python in a second right here.
Okay.
But a couple of things that I've been listening to and that have sort of come up. The first thing on the PyRevit side, I know that we've just implemented a PyRevit add-in to the add-in. So the parent company BIM1, Jean-Marc does a lot of stuff for us on the Dynamo side and things like that. And he's tied in a little add-in that we have that has a bunch of program he's created in Python as tab inside of our Revit files, but also we can now have some Dynamo graphs that are actually embedded in that same ribbon. So we can run some Python, we can run some Dynamo, we can launch a template, and all of that's in our own little tab that's inside of it. And all of it sits on top of, or is because of, having PyRevit installed. So I mean, I thank you for that. It certainly made the life a lot easier with that. And talking about the Rhino.Inside, and you mentioned that it kind of all started with Grasshopper. I know very little, next to nothing about Grasshopper, but I've spent enough time with Marcelo Scambolori, for those of you wondering, and his sort of exploration about what Dynamo can do and what Grasshopper can do, and how this Rhino.Inside is allowing him to test both workflows inside of Revit at the same time. You know, make a graph or script inside of Grasshopper. He can then test that and run it and see what it does inside of Revit, and then he can do the same thing with Dynamo and then make an equivalent. And everyone kind of has their favorite. I'm a Ford guy or I'm a Chevy guy. It's equivalent when we're looking at Grasshopper or Dynamo, but the fact that if you do a lot of Dynamo stuff, but then you need to go into Grasshopper, being able to have that common handshake, if you will, of being Revit in this case, it makes it a lot more comfortable. It doesn't seem as scary to try something completely different. You know, back in the day when the workflow used to be, you would open up Rhino and you would do some Grasshopper and you'd send Grasshopper through to Dynamo, and Dynamo would send that through into Revit, and you'd run it and you'd test it. It's kind of like the C# analogy you were saying, where you would test you to it and then you would wait. It goes from here to here to here and then back down, and then it's not right. You got to go back and start it again. So this just brings it all so much closer together and makes it so much easier. And yeah, that's it. That's my brain dump now. So
talking about the Grasshopper, and sort of like how easier it is for people to adopt it. It's all visual. Like, it's still, you could argue that it's a visual programming language. It's still a programming language. It's just purely visual. And just being able to see how these things connect to each other and not have to worry about all these conversions and stuff like that needs to happen on the back, and just seeing how your logic is connected through wires and whatnot. It's so popular that you could see it in almost any professional software. Like Blender has it for shading, Maya has it. That sort of like is one of the first applications that actually started using this kind of graph stuff for like 3D scenes and whatnot. Grasshopper is really powerful in that regards, that its visuals are so beautiful, and you can configure them, and you can take full control of the shape of that node and stuff like that. There's no limitation, so you can come up with really cool stuff. Like, you can see the color selector in Grasshopper is super nice, and they kind of all look different from each other depending on what applications they're being used for. This is one of the things that I was always interested in. As a programmer that knew programming, I kind of didn't need to have a visual environment to write programs. But once you actually start using it and get used to it, now I find myself a lot more being inside Rhino.Inside.Revit in Grasshopper, testing stuff instead of actually writing a Python script. Like, because then you have templates and whatnot, and you can throw the stuff in and you can connect things together and start inspecting things. So it's interesting, but I think it's really important to have a healthy combination of both of them in any production environment. There needs to be an engine that can run your script, and a visual front end for that engine that gives you the components and the visual environment that it can connect things together. And as you get better and better and want to create more and bigger applications and whatnot, then you kind of have to get into, hey, I need to write this in a script and make it into a module or a component that I can reuse later.
Absolutely, and I think you brought a good point about the visual programming and how you don't necessarily need to know the syntax. You just kind of see it and learn it. And for me personally, before I did anything that even remotely resembled programming, except maybe my VIC-20 back in the late 80s, which is totally different type of programming, but we're learning through Dynamo and learning the visual stuff, and just some of the ideas behind the logic in a visual way made it, when I had to learn a syntax, it just made more sense. You know, it's kind of human readable. It's sort of, you don't have to have 3 spaces and colons, all that sort of stuff, but knowing that you walk through it visually and you understand what it is, even if you don't really know why it's like that, it made it a lot easier. So I can certainly see how using something like Rhino.Inside input version of that you're doing here really does help bring that through and help the process. And I know that that got me more excited about doing further down into coding. Maybe not full on computer science coding, but just enough to know what I can do and what I can't do, which I always say is one of the biggest things, knowing that that's a problem that I can probably Google, find a few things and help that, or that's too much, that's not something that I can do, but I know where to go to get help with it. So that's, again.
And I don't know, like the computer science, the sort of like the computer science part that you mentioned, there was a time back in the computer science history that people would sit and write like faster algorithms to sort things and store things in memory and whatnot, or like, you know, hash algorithms and all that kind of stuff. We have figured out a lot of those things, and they live in libraries that they're sort of like used everywhere throughout the rest of the software. Most of the software development that's happening in the world right now is composition. Like let's call it puzzle programming. You're just taking things from different pieces and putting them together and know enough of how to connect them to be able to debug while they're not working and whatnot. But it's really like a front-end developer's skills are in like the choice of these puzzle pieces that they make and what pieces and how they compose them together to get to what they want. Like very few actual computer scientists actually in the world have to deal on a day-to-day basis have to deal with, hey, I need to make an efficient array of these things, because you have all of this stuff built for you in libraries and stuff. You don't really have to worry about it as much.
The power of computers these days is a lot more forgiving, right?
Exactly.
You don't have to
That's
worry
very true.
about saving memory and
half the time you don't, like for a couple of years I've been using PyRevit and I didn't even realize there's a memory leak in it. That like after a while using it, it just eats more and more memory from me. Just because you're running on, like, you know, massive computers with a lot of memory and it's very forgiving.
So speaking of memory leak, really absolutely nothing to do with it, but I thought it was a good segue. Seeing as this is an episode where we're actually here taking advantage of Zoom and the video, this might be a good time maybe to pass over to you, Ehsan, to see if maybe you've got a little magic back there that you want to show us, so the viewers that aren't listening and are watching, maybe there's something you can demonstrate with us. I know something that might be worth showing, because it came up as one of your most popular things in PyRevit, is in fact the pattern maker. Again, not trying to put you on the spot, but
no, that's fine. So I guess I can start sharing the screen and if my mouse works. Let's see if I can figure this out.
Wow, look at that.
All right, look at that. We see PyRevit.
Sweet.
Nice.
Yeah. Okay, so for any of you that haven't used PyRevit before, go to wiki.pyrevitlabs.io. That'll take you to the Notion page that is for PyRevit. This is generally how I start introducing PyRevit to everybody, because it's I've put a lot of time and care into this wiki. It has a couple of different pieces. Just touching them in sort of like in a very bird's eye view. Getting started helps you understand what PyRevit really is. It's mostly about using the tools and developing the tools for your platform. And it has guides and introductions and getting started for both of these aspects of PyRevit. And then it'll guide you how to stay updated with the new stuff, reporting your issues, and getting involved with the project if you want to get involved and contribute your code, you know, any way you want to support the project. One of the most important pieces of this is the developer docs. If you want to develop and use PyRevit for development of your tools and everything else inside the Revit environment. And it has ways, sort of like guides on how you get you started. One of the things that you notice that PyRevit is not about Python only anymore. You can run CPython, VB.NET, C# as a script inside the PyRevit environment. It runs all these different languages for you. So just as you can easily make changes to a Python script and rerun it, you can actually do the same thing with a C# script and rerun it. It does the automatic compilation and stuff like that in the backend. It familiarizes you with the concept of the bundles in PyRevit, that, hey, bundles are just directory of things. You can put a script in it, you can put a tooltip in it, you can put a family in it. If you want to place a family automatically inside the Revit model, you can make a bundle that's what I call it the family bundle or a content bundle. This deploys a specific family to your users if you want to use them. So it's not about just running scripts anymore. There's a lot of different things that these bundles can do for you. And then gives you like examples of like how you can use the actual scripts. Some of the things like effective output, there's guidelines on, hey, if you want to print stuff to the users. Like these are the utilities that you can use to show progress bars and tables and all that kind of stuff to the users. So there's a lot of information in here that you can learn about PyRevit and the multiple different aspects about it. I also have a course that's sort of like a Python plus Revit API course on YouTube. I keep adding to it every time I have time these days. But basically, the first part of it, which are all this like dark blue stuff, they'll teach you how to deal with the Revit API from the Python perspective. I'll get you started with the necessary tools that you have, the RPS, the documentation for the Revit API, and it sort of like teaches you through, hey, this Revit is actually a database, and you kind of have to learn how to create things, modify things, delete things, and update things and whatnot in that way. And it takes you through each one of these and say, hey, like create stuff in Revit works this way. Here's the API, here's that, here's an example. So it's a good starter course to get into Python development for Revit. It doesn't teach Python, but you'll get to see a lot of like, you know, how Python is actually being used with Revit. Let me actually, so like PyRevit also comes with a command line utility that I can say, let me see, PyRevit environment, and I'll give you a full list of what the environment is and what Revit versions you have installed on your machine and what version of the system you're running, and a lot of like other stuff, other information about PyRevit. So I can say PyRevit attach my, let's say, dev branch with the engine 277 to all installed Revits. So next time when I launch my Revit, PyRevit is attached and it loads at when Revit is loading. Now this is going to be slightly slow because I'm like running everything in a virtual machine. Let's see if it really works.
I love your Revit logos, by the way.
So jealous.
Yeah, actually, I'm thinking of putting this on a repo too, because it's just an installer that installs a series of shortcuts for you. So it'll go here, and they're called where is it? Revit version icons. They get a whole bunch of these, and basically you just click on and you just put them on your taskbar and stuff. The actual Revit icons.
Nice.
Especially for us that have to install multiple different Revit versions. Also read that Autodesk is giving, it's increasing it from 3 or 4 versions to 5 versions now.
Oh.
Yeah, so you can have, if you have 2021, you get access to back to 2016.
Yeah. I'm not sure it's increasing, it's just no longer bothering to decrease.
That's true.
Subtle difference. That's too much work to cut that license off.
That's true. So it kind of helps with keeping it really sane.
Sorry, speaking of freebies, I believe you've also like shared a bunch of like accessibility details. Like, am I getting that right?
Yeah. So I call them the Revit cheat sheets. Wait, where are my repos go? Why doesn't look right? Okay.
Scared you for a minute.
Cheat sheets. There we go. So it's on my GitHub repo, Ehsan dash cheat sheets, and there's a whole bunch of PDFs basically that you can keep adding to it too. It's an open repo. One of the things that I really like, I get good feedback from people is like Revit stair types. Hey, like understanding how different stairs work in Revit is kind of hard. So it gives you a PDF of like, you know, exactly how many different types of stairs that you have, how they come up together to form that stair that you design and whatnot, and what pieces they do. And it's not very visible from here, but if you open it in actual like PDF editor, you can zoom in. There's like a lot of details in there. So you get the same sort of like visual cheat sheet with points and arrows and all that kind of stuff for a couple of different categories that I've made it for.
You know, I find myself making those not as pretty, but in different things for trying to program. So I can see why you made those. Because you figure out the way the stairs are and what each of the things are, so that you can change them up.
Yeah, and they're pretty neat concepts. You kind of have to take notes every time you look at them, because you can't possibly remember all of this like nesting structure all the time. So when you launch PyRevit, this is the window that you see that we call it the PyRevit output window. It's actually an HTML window, so you can, you know, spit out emojis and images and tables and all that kind of stuff and charts and whatnot. So it's a pretty powerful output window. It has a couple of utilities on the top that you can save and copy and share stuff, information about the PyRevit version that you're running and whatnot. But basically, that's PyRevit's way of telling you, hey, I loaded and everything is fine. And then let's get to a project. Let's use Imperial. This machine is not the fastest machine.
All right, we'll cut all this out.
Okay, so like I have a project open now. I installed this plugin because we have a conflict with it, so it's all a lot of different windows now. So you get this PyRevit tab that has a lot of the PyRevit tools in it. They're generally grouped in like toggles, selection, analysis, modify, things that you need to use to deal with drawing sets, projects, and like wiping up the project and whatnot. One of the really good utilities as just a new PyRevit user is this get Revit Info. So if you click on it and open any Revit model, this is one of the use cases that we had at the company a lot, that you could go to, let's say, any model and double click on that model, and it gives you a report of what version of that model Revit has been used to create that model, sort of like the last saved path and the project information and all that kind of stuff. It's a really good thing to kind of have this on the side so you know which version of these Revit models you're dealing with. There is a PyRevit panel here that gives you access to the PyRevit related stuff like the extensions and about and its settings and whatnot that I won't get into. But to show you the make pattern tool is the one that's here. And it has a pretty good description of what it actually does. But today, maybe we talk more about this and the sort of like the hidden features and whatnot that it has. If you want to get access to a bunch of patterns that you can test and whatnot, PyRevit has this feature that if you alt click on their tools, it'll take you straight to the script that actually is sitting behind that tool. So it has this system that has, you can use the modifier keys on your keyboard to change the behavior of that tool. So like, for example, Manage tool has a black dot in front of it. That means if you hold Shift and click on it, it'll give you the options for that tool instead of actually running the tool. So it has this like multiple different modes. And that's one of the things that I picked up from Maya. Maya has this feature. Every Maya option has like a square thing on the side that you can click on the square and it gives you the options for that tool. But inside this, there's a test directory and a whole bunch of, there's a Revit model that actually has a lot of like different examples and whatnot that I used when I was making that tool. So I'm going to open that, and it has a lot of like different shapes of patterns and stuff in here. Let's open the model tests. So this is what I use. Like I brought a whole bunch of patterns in here and started building them to actually test the tools, different angles and sort of like different shapes and stuff. Now, let's go and create one that we want to create. Generally, what I do is that I draw a square because it works based on the concept of tiles, right? So I have a 10-foot by, let's call it 10-foot square. And then inside of it, I want to draw my pattern. So I just use, in this case, I'm just using model lines, or you can use detail lines to draw it. Let's go here and say, hey, I might have a couple of boxes. And you can actually use the curves in Revit too. PyRevit automatically sort of like splits this curve into different pieces of like tiny lines and uses those to create the pattern. So you get the effects of a curve. And then select what you want to be part of your tile. And this assumes that, hey, if you have designed this tile, this is a tile that's going to be repeated just like a tile like this, right? So you can come up with all sorts of like shapes and whatnot that get repeated correctly. You might have to draw a couple of these repetitions to get to the actual cell, the core tile. But eventually you'll select all this stuff in the tile and you go to PyRevit, say make pattern. In this case, I want to create a model pattern. So I'm going to call it like a crazy pattern. And then you can create a field region automatically from this pattern if you want to with the same name. And the rest of the stuff, we'll talk about it. And then you can either export this as a pattern file or you can create the pattern. And it would say, hey, give me the corners. And say, this is the starting point of the tile, and this is the other point against that. And it would create the pattern for you. Usually takes less time. And then I can go and create a field region. and select that field region as my pattern.
Look at that.
And it creates the pattern. And then in this case, this is a model pattern, so you can actually select all these lines and make changes to the alignment and stuff. So it, you know, as far as Revit cares, it works and behaves just like a Revit pattern, whether it's model or
Well, it is
the
a
other
Revit
stuff.
pattern.
Well, so Revit patterns are built based on the concept of the patterns that came from AutoCAD. So
Yes.
the underlying architecture of the Revit patterns are exactly the same as what AutoCAD was.
Oh, okay.
It's just not exposed to the user, so you can't really create that. That's why you can easily export this to a path file, because the underlying design is exactly the same thing.
Right.
So I can go and select the pattern that we created, select the units that I want in, and then export it as a pattern file and save it, let's say, to desktop. Wait, one.
Doesn't like test file.
Yeah, oh, actually, sorry. It wants to select the folder.
Oh.
And it would automatically create the same file for you. So if I open this, don't mind this. Okay. You get the same sort of like a pattern file that you get they used to work with AutoCAD. It
Boy,
just
I
has
don't
this
miss
extra
those.
thing. Yeah. And they're really hard, you know, every single person that has made those, they're really hard to create, almost impossible at some point to create them manually. It only has this extra tag that says, hey, this is a model. So if you import it in Revit, Revit imports it as a model pattern. Other than that, everything else, you can import this inside AutoCAD and keep using it. One of the other nice things about PyRevit is that you can actually make changes to this pattern, and then you can go through the process again. Say PyRevit, make pattern, instead click that one again, and then click it and sort of like have it rebuilt, and it would update the pattern for you. So it's not a one-time deal. You can actually use it to do other stuff with. And let's say in this project, I don't know, let's say if I do have a pattern somewhere, let's create a new field region and go to model and see if you can find, well, we don't have anything in here, but let's just use that one. So one of the things that you can do is that now I have this pattern and I have another pattern, and I kind of want a combination of these two. So I'm going to draw another field region over this, and I'm going to use the other pattern. So this is what I want to get to, kind of. Let's put this one as a, where was it? Masking, it's not. Wasn't it? Used to call it like, I don't know. So kind of this is what I want to get to. So I can actually select two field regions and run the make pattern and say like combine patterns. And then create a pattern, pick the corners, that kind of a thing. And it would pick a combination pattern for you. So now if I go to field regions, I do have a new pattern. It's called combined. And it has both of them in the same pattern. So it takes the logic behind this pattern and the logic behind that pattern and puts it in the same pattern. So it's a great way of like combining these two. Or you can select this pattern and say, hey, it's not the right size. Let's do combined, but let's scale it by, I don't know, half. And well, you kind of have to, let's make one piece of it on the side. And then you can say, yeah, I want to maybe scale it and then maybe flip it horizontally or something like that. And you select the name of your pattern and say the exact same thing again. And it would reduce the size of it, and it would turn it, flip it the other way and whatnot. So you can actually use it to, like if you have a stone pattern, you can use this tool to rescale that stone pattern in different pattern names and different scales, and kind of use it in your project the way you want it, to fine tune it for your project. So it has a couple of like really good hidden features that's super helpful.
That's great.
And that's been one of the most popular tools in PyRevit to deal with Revit patterns.
Absolutely. Well, thank you so much for joining us today. We have we've gone through 2 Aubins on this one. It's a miracle.
That's an hour.
It's an hour to you and me. Yeah, because Paul Aubin, you know Paul Aubin, he listens to BIMThoughts at double speed. So it's
oh, nice.
And then we found, well, first he wanted them, says they're too long, need to be half hour. So we said, all right, we'll do that, which made the editing easier. And then we found out he listens at double speed. So an Aubin is really 15 minutes. It's four Aubins long. All right, well, thank you so much. And we're going to have the links in the show notes to all of these great sites. Very happy you're able to join us today.
Thank you.
Very excited. And I know Alexis is excited.
Thank you
I
so
know
much.
Dana is very excited. We can tell because she smiles a lot. And
smiling.
Carl's Carl, but he's excited too, I think.
Super excited.
All right. Thank you so much. And make sure you go out and have a great day. Oh, and visit my YouTube channel where I use all the tools behind me. It's called Bill's Workshop or Workbench. Called Bill's Workbench.
I'm going to check it out.
You check that out. And subscribe. I need more subscribers. All right. Thank you so much.
Thanks, guys.